This projectile motion problem says that an athlete puts a 16-pound shot at an angle 30 degrees to the horizontal from 6 feet above the ground at an initial speed of 44 feet per second. How long after the launch and how far from the athlete does the shot land? So here are our x and y components. We will be using the y component because we want to know the duration of the launch in the sky and how long it takes to land. So we will be using this component. We will be solving for t. And to solve for t, since there's t here and t here, we have to use the quadratic formula. So remember, the quadratic formula is ax2 plus bx plus c. We will put this into this form. So you get y equals, this would be a, negative 1/2 g t2 plus b, which is here, v initial sine angle a t plus c. And if you see here, there's no c over here, right? But in this problem, the horizontal from 6 feet above. So initial would be 6 feet above. So you would add 6 to that. So c would be 6 over here. So here you have the quadratic formula. Now you need to find a, b's, and c's. So for a, let me move this so you can put here. For a, you get negative 1/2g. For b, you get initial of velocity, sine, angle. And then for c, I'll write c over here, you get 6, okay? Now, remember back in pre-calc, Calc, you had to find y equals negative b plus or minus this thing, b squared minus 4ac over 2a. So you want to do the same thing for this in order to find t, okay? So if you plug it into that formula, you get y equals negative b, which is initial velocity sine a, plus or minus the square root of b, which is initial velocity sine a squared, minus 4ac, which a is negative 1/2 g, c is 6, over 2a, which is 2 negative 1/2 g, okay? Now, if you look at this, this is a negative, this is a negative, so you can disregard that, okay? Now, what next? This is a 2, here's a 2 over here, cross the 2 out, that leaves you with g, okay? Now, what next? Can we simplify? Negative 4 times negative 1/2, that would simply be 2, so you have 2g right here. What next? Now, you need to distribute the exponent 2 for the velocity, initial velocity, and for sine angle, okay? So what you will get is, you would get this. V squared sine squared a, okay? So we know that the angle is 30 degrees, so sine 30, you get 1/2, right? But you want to square 1/2 because the sine is squared. So let me simplify this one more time. You get 1/2 squared, okay? So same for here. Sine a is 1/2. We could change that as well. Sine a 1/2. Okay, so now all you need to do is to plug and chug. So initial velocity is 44. So anytime we see initial velocity, we write 44. 44 here, 44 here. And then, okay, that's it for initial velocity. anytime we see G, we write we write 32 because the acceleration due to gravity is 32 feet. Okay. $32. Okay. Now, all we need to do is plug that into a calculator and then solve for t. So, 44 times 1/2 plus the square root of 44 squared times 1/2 squared plus 2 times 32 times 6, all that over 32. This will give you 1.608. Okay, 1.608. So this value is t. Now, that you know how long it took for the shot to land, 1.608. We want to find how far from the athlete does the shot land. Okay. To find how far, remember how we had x and y components? The x is initial velocity times cosine angle t. And then y is equal to initial velocity times sine angle t minus 1/2 gt squared. Okay, so we did that. Disregard that. We now want to find the horizontal component, which is the x component. We want to find how far from the athlete does the shot land. So we have t, we have the initial velocity, and we have the angle. We could just plug and chug. So initial velocity, 44 feet, cosine angle A, which is 30, times time, which is 1.608. Okay, plug that into a calculator. 44 cosine 30 times 1.608, you get 61.27. So this would be how far from the athlete the shot landed. And this is how long after the launch the shot landed.